All right, in this video, we're going to talk about section 4.7, a change in variables for multiple integrals. It's important to recognize right off the bat that this section is going to be trying to help us update our notion of a U substitution that we had back in a Calc 1 class. Now at the top here, I kind of briefly outline exactly what a U substitution in Calc 1 actually looked like. The idea is that if I had a particular function I was attempting to integrate, and if in place of x there was like an entire function of u's, and if I had then my bounds able to be changed over by this function, notice like my bound of a could be found by plugging in a specific value for u and calculating out that value of a, and similarly for the value of b. Well then, as long as the derivative existed and was continuous on the closed interval, we know that we had this relationship down here. That is, we could take a complicated integral over here on the right side, and we could simplify it via the substitution coming back to the left. So this was at least the idea of a U substitution. Again, what we would say is I could take something messy and spot its derivative in the integral, and then I could swap things over. And as long as I also change the bounds, I know that everything would be good. So what we want to try to do is to understand if this is something that might hold for like double and triple integrals. Could I do some sort of a U substitution, not just on one of the integrals in that double or triple integral, but on like the entire double integral or the entire triple integral? Well, what's kind of cool is that actually in section 4.3, we already did something like this, and you can kind of see how it works. I'll even state here that in section 4.3, we used a change of variables on a double integral. We changed specifically in that section from rectangular coordinates to polar coordinates. So here's ultimately what we saw. We saw that if we started with a double integral over d of some function, f of xy, dA, what we did is we let x be equal to r times the cosine of theta, and we let y be equal to r times the sine of theta. And then what we were able to conclude is that this double integral over d was able to kind of be transformed into a double integral, let's say over a different region, maybe like a region S, right? We had to kind of like change the bounds and rethink about how we imagined that region. And then we also had to kind of reimagine our function. In place of all of our x's, we had to kind of update and maybe put in r's and cosines. We had to do r sine in place of my values of y. And then, of course, at the back, in place of that dA, remember, we always put an r dr d theta. Okay. So it was important to note that S here is something that we were visualizing as being a part of the r theta plane, if you will, and d was something that was a part of the xy plane. So what we were kind of doing is thinking about, again, the idea slightly, thinking about the volume underneath this particular surface of F and above D, and kind of remorphing it. And you can see that when we do this, a bunch of different things are going to change. And these are the same things that change always when we do some sort of a substitution. You can see here that my function has changed, right? I have to kind of briefly modify my function. And we have to do the same thing up here in a U substitution. We took a messy function in Calc 1 and we did a substitution and the function changed over. We have to change the bounds, right? In this case, we're changing the region that we're integrating over. So here I might have had bounds of C to D, and then here I have bounds that go from A to B. But I also have to change kind of this dA at the back. Just like in a substitution, I often had to kind of replace dx or du with something. And so here, this dA, this dx dy, had to be replaced with an rdr d theta. Okay, so what we're going to be trying to do then in this section is to understand how could we conduct a change of variables just generally. And what we'll see is that we don't necessarily just need to worry about substituting out one variable, but we'll see in this case, I kind of have to have multiple substitutions in play. And we're going to see how all of that works in the creation of what we call a transformation. And we'll take a look at that in the next video.